video, we're going to use the regression capabilities of our calculator to find our regression equation for p as a linear function of t. We'll just round our coefficients up to two decimal places. And then in the context, we're going to interpret the slope of our regression line. So, since we're doing linear regression, first thing we're going to do is go to Stat, and we're going to edit our lists. So we hit Enter. I've already put in the data for my lists. You always want to make sure that your lists are the same length and that your data is entered correctly. Now we're going to go to Stat, Calc, Lin Reg. Depending on your version of your TI, you might get this list here. It tells me I want to use the X as my L1, Y as L2. You can always change that there if you want. Calculate. And there's my linear regression function. So let's go ahead and write this out. In terms of the variables they gave us, they wanted us to use p as a function of t equals, there's my slope, negative 0.25. And then our input, we're using t plus 5.99. So there's our linear regression line for this situation. Now our slope, m, equals negative 0.25. And if we look at the units on that, it's parts per million of carbon monoxide pollutant concentration per year. So if we want to describe what's going on, it's negative, so that tells us it's decreasing. What is it that's decreasing? The carbon monoxide pollutant concentration. So what we're finding out is the carbon monoxide pollutant concentration is decreasing on average by about 0.25 parts per million per year during this time period from 1990 to 2003. So it gives us the amount that the carbon monoxide pollutant concentration is decreasing by on average per year.